last thing that we need to look at is using completing the square, which you're familiar with from Algebra 2, pre-cal, to rewrite our denominator in a form that's going to give us an inverse trig integral. Okay, so 16 here, this comes from a different curriculum, by the way, so that's why it's not in the normal notes handout. But anyway, so this number 16 here, we cannot do a u substitution because the derivative of that is 2x plus 10, and there's no 2x plus 10 in the numerator to sub out for the du. All right, so we need some other process here. So just a quick reminder of how you do completing the square. So you take your denominator, x squared plus 10x, and you put a plus blank there instead of the 29. And then we still have the 29, it's just down on the outside. And to cancel out the plus blank, we put a minus blank. All right, and so to get that blank, you take the b value, which is the coefficient of x, and you divide by 2, which is 5, and then you square that number, and you get 25. And the reason this is helpful is because this thing factors into x plus 5 squared. And then 29 minus 25 is 4. All right, so let's rewrite our integral now as 1 over x plus 5 squared plus 2 squared dx. Okay, and so this is pretty much in the form of an arctan. X plus 5 is our u squared plus a squared is an arctan. We don't need to actually do a u substitution here because the derivative of x plus 5 is just 1, and so there's no reason to actually write out the whole u substitution. You only really need to write it out is if you get an extra constant that you have to divide by your integral, or if there's like an x or something else, some other variable involved. All right, so our arctan is 1 over a arctan of u, which is x plus 5, divided by a, which is 2, and then we're doing an indefinite integral, so we need our plus c. Alright, so 17 can work in a similar way. This one's a little bit trickier on the completing the square, so I'm going to factor out a negative from this, so that'll make that a positive x squared and a minus 8x plus blank, and then we don't have an extra constant, so we just have a minus blank out here. Alright, so we take our b value, divide by 2, which is negative 4, we square that, and we get 16. But over here in this blank, we have to remember this negative we took out would distribute to that. So that's actually going to be a negative 16. So this turns into negative x minus 4 squared, and negative times a negative is a positive 16. Alright, so let's rewrite our integral as 1 over the square root. And I'm going to put the positive number first, and I'm going to rewrite that as a perfect square, 4 squared, minus x minus 4 squared dx. Alright, and that looks like it's exactly in the arcsine format that we want to see. Alright, we have a squared minus u squared. Once again, our u is, the derivative of that is a 1, so we don't actually need to write out the u substitution. Alright, just kind of keep that in mind as you're writing the integral. So this is an arcsine of u, which is x minus 4, divided by a, which is 4, and then don't forget your plus c. Alright, and that pretty much does it for the new stuff. I'm going to do a few more problems down here at the bottom that are very similar to the last part of part 1's video, where we're looking at different problems that look like they might be an inverse trig, but they're not. Or they might be sort of half inverse trig or half something else. So if you feel like you kind of understand that idea already, you can try a lot on your own and kind of just skip to the answers, or if you want to see me do a few more problems, then I'm going to do that. So I do encourage you to try all 6 of these on your own first and see how you do. And then just come back to the video, and if you really struggled on one, you can watch the whole thing. If you want to skip to the answers, that's fine too. We'll see how much I can get done in the 10 minutes I have left of recording time. Alright, so this one looks like it might be an arcsine, right? We have a square root of a squared minus u squared, but we have this x on top. So remember we talked about how if the exponent of the numerator is 1 less than the exponent of the denominator, that's usually a u substitution. All right, so let's try u substitution. All right, derivative of that is going to be negative 4x dx. So there's our x dx, going to sub out for du. We just have an extra negative 4 constant, so that goes in front of our integral as the reciprocal. Negative 1/4, 1 over the square root of u du. All right, and so that is an integral that we can do. Remember, this is u to the negative 1/2, so that becomes u to the positive 1/2 divided by positive 1/2 plus c. Okay, this is going to multiply by 2, so that's going to become negative 1/2. And then u to the 1/2 is the square root of u, and then we can plug our u back in. 5 minus 2x squared plus c. All right, this one looks like maybe an arc tan, because we have an a squared plus, this doesn't really fall into the u squared category, I wouldn't think, but I could see how someone might think, arc tan, because of the way it's set up. But when you're dealing with e to the x's, if you have an e to the x in the denominator and an e to the x in the numerator, remember the derivative of e to the x is e to the x. So this is telling me u substitution once again. U sub out that denominator. The reason you want to u sub out the denominator is because if we get a 1 over u, we know how to integrate that. So du is equal to e to the x dx. So don't even have an extra constant this time. This literally turns into 1 over u du. Integral of 1 over u is natural log, absolute value of u, plus c. Plug your u back in, and since 9 plus e to the x is always positive, we don't need the absolute value parts. Just regular parentheses will be fine. All right, when you're dealing with trig, especially sine and cosine, because we have that cyclical nature of their derivatives. So if I see a sine in the denominator and a cosine in the numerator, once again, that's kind of telling me I should be doing a u substitution here. So u equals 1 minus sine. Du equals, so derivative of negative sine is negative cosine of x dx. So our new integral is going to have a negative in front of 1 over the square root of u du. All right, so our integral part is going to be very similar to number 18 over here. So we're going to have a negative, and then that's going to be 2 square root of u plus c. So I just kind of skipped from the u to the 1/2 over 1/2 to the 2 square root version, since we already did that over there. And then just plug our u back in, so negative 2 square root of 1 minus sine x plus c. All right, so 21 down here is a little trickier. If we try to jump straight into a u sub, we're going to run into a problem. So just show you that real quick. U equals 4 minus x squared. Du equals negative 2x dx. And while we have the x here, this plus 2 is a big problem. All right, we would need like an x plus 2 dx instead of a negative 2x. So u sub doesn't work initially, but I'm not going to erase it because it does work in a different way. So what you actually need to do here is rewrite this integral. We can split this up into two integrals because the numerator has two terms. So one integral can have just the x over the square root, and then the other integral can have the 2, and actually I'm going to put that 2 in front and put a 1 over the square root. So that u substitution now works on this integral. We u sub out the 4 minus x squared, we get the negative 2x dx, so we're going to get a negative 1/2 in front of our new integral, and we just have 1 over the square root of u du. This integral is an inverse trig. We have a constant on top of 1 over our thing, so I am going to still rewrite this so we can identify our a value. That's 2 squared minus x squared dx. All right, and now we can integrate. So integral of 1 over the square root of u is 2 square root of u plus c. And then integral over here will be 2, and this looks like an arc sine of x over 2 and plus c. All right, so the 2 and the 1/2 cancel, so we end up with negative square root of 4 minus x squared. And then over here, these c's are going to combine together, so I'm going to get rid of that c right there. So this will be just still the same thing. And then just a single plus c at the end. All right, you can try a similar thing on this one. So if y'all want to kind of try that, hopefully you were trying them on your own already, but if you haven't been, try this one on your own for sure, using this template that I just made over here. All right, so we're going to split this up. All right, the first integral can be done with the u substitution. So we end up with an extra 2, so that's going to be a 1/2 in front, 1 over u du. This integral we're going to rewrite with that 2 in front and turn that 4 into a 2 squared. All right, so this ends up with a 1/2, and then the integral of 1 over u is natural log of the absolute value of u. This integral is an arctan. Actually, arctan has that 1 over a in front, remember. So instead of it being 2, it's going to be 2 over 2, arctan of x over 2, and then plus c. All right, little cleaning up to do. We need to plug our u back in here. I'm actually going to pull that 1/2 up as well. So this is going to be ln of the square root of x squared plus 4. 2 over 2 cancels out, so plus arctan of x over 2 plus c. All right, last one, we talked about improper fraction, the top heavy, or if it's balanced. So improper fractions, we want to do long division. So x squared plus 1 goes into x cubed plus 0. So what do we multiply by x squared to get x cubed? That's an x. So we get x cubed plus x. So I'll call this 0x there. Switch your signs, so it turns into a minus and a minus. Those cancel, and we get negative x as our remainder. So that turns into negative x over x squared plus 1. All right, so our new integral will be, and I'm going to write this as 2 separate integrals, so the integral of x dx minus the integral of x over x squared plus 1 dx. All right, so the integral of x is going to be x squared divided by 2. And this integral looks like we can do a u substitution. X squared plus 1 du is x dx. So that's going to sub out perfectly. So minus the integral of 1 over u du. So x squared over 2 minus the natural log of the absolute value of u plus c. And then plug your u back in. So x squared over 2 minus the natural log of x squared plus 1. Never a negative number, so we don't need the absolute value bars. And then plus c. All right, thanks for tuning in, and I will see y'all for whatever else we do this year. All right, caught a tiny mistake here, and I didn't want to re-record the whole thing. So just at the very end here, I did the wrong derivative. Derivative of x squared is 2x dx. So our new integral should have had a 1/2 in front of it. So our natural log should have had a 1/2 in front of it. And so we can turn this into the square root of x squared plus 1, just like we did on the last problem. All right, thanks.